Yes. Good afternoon, ladies and gentlemen. I'm glad to be back at the podium. I'm going to give a short presentation about the project which I'm currently engaged with my UK and Russian partners. And the presentation that I have here I didn't construct, which is why I very carefully not changed the author of the orders, the order of the authors. So the title of the project is, as you read here, Multi-Scale Remote Sensing to assess parameters of the northern forests of Russia in the context of climate change. And it's a collaboration between 5 institutions, 2 in the UK and 3 in Russia. And you see the names of the institutions here on this first slide. So it's a Russo-British project. It has 5 partner organizations. It began in 2018. It finishes, well, we'll say 2020, actually technically just slightly into 2021. And the financing for this project, it's simultaneously funded in the UK through the British Council and in Russia through the Ministry of Science and Higher Education. So, something's gone slightly wrong with this slide. So the overall goal of the project is about the development of technology and development and application of technology. So to assess the dynamics of phytomass of northern forests in the context of climate change with a timescale from the year 2000 until now. So what we have slightly lost in the slide here, underneath the expected results, is the idea that the validation for this project will be based on a number of key sites. This is quite strange, actually, what's happened to the slide in general. I'll cover these points in a later slide. So we have technologies to assess the characteristics of individual tree stands using very high resolution imagery from satellites and from drones, from UAVs. We have technologies to map tree stand structure and forest tundra ecotone using coarser resolution imagery from satellite systems, Landsat and Sentinel, and we scale up, as I will explain in a later slide, using MODIS data so that we have a spatial coverage which lets us look at the whole of the Russian boreal forest. So these are our research objects. Very quickly, we identify them at a number of different orders or degrees of generality. I'll jump straight onto the next slide because I know I'm quite short of time. This slide summarizes our research design. So we have the 3 domains here. We have forest parameters, which we categorize by timescale. We have a set of monitored phenomena, and we have a set of climate and weather data, because the project is motivated by understanding the influence that climate change parameters are having on the growth and change in form of the boreal forest. We know there are parts of the study area which are subject to strong anthropogenic influence. We exclude those from the analysis, so we're trying to focus primarily on the climatogenic influences. So it's a multi-scale project. It has to be a multi-scale project because it has to range from things at the scale of individual trees or smaller than that, all the way up to the scale which is accessible from MODIS imagery. So you have to read this slide from the bottom to the top, unusually. So we have tree stand parameters which include a leaf area index, growing stock volume within our study areas, which we can access through field survey and the use of drones. We scale up to the next spatial scale using the drone data and using the relationship between Landsat type imagery and MODIS imagery. And then the final stage, which actually we already heard quite a little bit about this morning from Nikolai Shabanov, focuses on the use of MODIS imagery. So these are our 2 model territories, our study sites that we've used so far. One is based in the Khabini Mountains on the Kola Peninsula. We did a major field program there in 2018. It's an area we know very well. It's the Moscow State University Geography faculty has a field station there, so it's a convenient base to study from. That's been used extensively in 2018, also in 2019 for data collection, and also in summer of this year, in 2019, we based ourselves in the Sakha Republic at the field station in Spasskaya Pad, and then some field sites that we invented for ourselves slightly to the east of the Lena River. Mostly, we did some on the west as well. The project is mainly financially supported, as I described, from the British Council and the Ministry in Russia. There is some ancillary funding streams as well, which come through actually through the Science and Innovation Network and through the UK Foreign Office, which allows us to enhance the fieldwork with activities related to the further exchange of staff and students, public engagement and so on. So we're able to increase the impact of the project in that way. So it's a multi-scale project. Our domain is the whole boreal forest region at a MODIS resolution, so let's say nominally of the order of 1 kilometre, a little finer in fact. The temporal domain is the present century, so from the year 2000 till now, or till 2018, with a nominally 1 year resolution. The range of scales that we consider is from, well, around the centimetre scale. We have field hyperspectrometry at that kind of scale, through the centimetre to tens of meters, hundreds of meters scale, through drone imagery and through Landsat and Sentinel imagery, and then the coarsest scale and the widest coverage we achieve through MODIS imagery. So fundamentally, we have remote sensing data calibrated by a lot of field measurements, and as I said, we've got 2 field seasons completed so far. So I'm short of time, I will go quickly. Here is some example data from one of our sites. This is one of the sites in the Hibini study area, site 16 for us. So on the left we have aerial imagery collected from drone data. We have normal terrestrial imagery on the right to show the typical forest configuration. Okay, you can read the words. This is the kind of ground-based research and UAV data collection and processing that we use. Here is an example, if you have questions about that. I think Andrei Medvedev is in the room somewhere. So our partner institution, which is the Institute of Geography of the Russian Academy of Sciences, is responsible for this part of the project, the drone data processing, to generate point clouds from the drone data. From the point clouds, they, in fact, can classify between trees and ground surface, and from that we can calculate the crown cover. So we're as a project team, we're getting quite good at classifying, extracting a range of forest structural parameters from the drone data. This is the work that Nikolai was talking about earlier this morning, so it's not my job to describe his work. We've seen this already. Here we have the processing of the LAI product, the IKI product, not the NASA product. This we've already seen. So let me just, since my 10 minutes are nearly up, just say that the climate part of the project involves, in its current phase, involves identifying the best kind of locally tuned climate reanalysis data sets to describe the climate variables we have. So that involves collecting a lot of in situ climate data, comparing that with what the reanalysis data products show, and picking which one does the best job. I don't think we know the answer to that question yet, but we will soon. So to summarize, that's what we're trying to do. That's where we've got to. We're kind of about halfway through the project, maybe 2/3 of the way through the project right now. So we've got quite a lot of, actually we've got a huge amount of field data under our belts already, and we are grappling with processing the field data and connecting it to the coarsest resolution satellite data. We may squeeze one more major field collection in next summer. We're still discussing that. And that, I think, very, very quickly is what I want to say about this project. So thanks for your attention.